Just recording this for posterity purposes. I'm here with Pi Studios. Say hi.
Hi.
We're creating an 8-bit memory cell. This is half of which. This is the portion that actually saves the bits into memory. And these wires that are over here are being hooked up to an 8-bit multiplexer. So basically we're going to take, 2 wires per cell times 8 cells. So you have 16 wires coming out the end here. Each of those wires is going to go to an 8-bit multiplexer, which is going to narrow that down to 4 wires. 1 wire for either a 0 or a 1, and then 3 wires for controlling where it goes to. After that, the multiplexer is going to be hooked up to a system clock, which is going to sort through all the different memory cells. And then it's also going to hook up to a temporary 8-bit, almost like a RAM storage. So if I wanted to enter in 8 bits, I would enter in 1 bit, hit next, or whatever else, however I set that up, and then hit in the next bits, and those will all go into RAM. And once that's full, the system clock will take that and shove it into actual disk memory. I say disk memory because it's easier to distinguish between RAM and hard drive when you just say memory and then disk memory. So this is technically like a hard drive. Hello everyone, my name is Dev Deckard Kane, joined by Zach.
Yo.
From Pi Studios. He's using my account right now just because I'm using his beast of a machine to record, since my machine is crap. Alright, can I get you to power off the reset cycle while we start here?
Yep.
This is my 8-bit memory module, which is going to be used in my upcoming Minecraft computer. I used to have an old computer that I built a while back, but the hard drive on the server crashed, so I'm starting over again. This is 8 bits, as I said before. Each memory module is located here. Each one has 2 levels. This is the first level, that's 1 memory module here, and 1 memory module on the floor. Each memory module is this big. This is how big they are. It's ridiculously small. The reason why the entire thing is so large is because it requires so many power lines to try and make this a lot smaller. So basically what we have here is our display of outputs. This is the reset switch. It resets all of the modules back to 0 and then sets the default 0 on. That's going to be changed later as soon as I get the data bus in. Each of these numbers are controlled by a multiplexer, an 8-bit multiplexer, which is over here. These are the controls. This is just another reset switch for me, and these are the controls to turn all the memory modules on. Each memory module has the functionality to read and write, this being the read and the other side being the write. This is all set up just for demonstration purposes for this video. Now what I intend on doing here is having this multiplied as many times as it takes for us to get at least 64 bits of memory. My plan is to get 8K memory, which is 8 kilobytes. So you can imagine how many of these it would take to make that. Though on this machine I don't think that chunks is an issue, so I'm sure that we'll be able to get that by. The main goal of having this is to record video, pre-programmed video from user entry inside of the game, and then displaying it in the cinema. So a cinema would just basically be a display of redstone torches or these new lamps that they've incorporated into Minecraft to create a bit of a motion picture. Now in the end you'll have 8K to do it in, so you won't have very many frames, and there will only be allowed 1 video per machine, each machine having its own schematic, so I'd be able to sell machines to people if they so desire. I'm also having networking built in with my other way of saving. So there's going to be a fully functional computer in the end of all this, and hopefully I can get this set up on a server so that each person will be able to have their own machine to use. I just want to clarify one thing before we start here. This is mainly for hard drive purposes. This is not intended to be RAM. The reason why I say that is this uses the Minecraft repeaters, which are really quite slow. For example, if I wanted to set this off, that would be how long it would take for it to turn off, because these repeaters are so slow. In the new computer that I'm going to build, the RAM will be instant. I'm going to build instant redstone repeaters. So there will be pretty much no lag. The only lag that you'll get is through the networking functions. That's because I'm using pistons to push blocks around to send data, rather than having wires all over the place. Perhaps on the server I'll put wires though. So to test, let me get out my truth table here, and we will see which lights come on. So Zach, if you want to head over to the other side there, I'll start turning on all these lights. Another thing I want to clarify is this area here is all just for testing purposes. The only thing that will be actually in the module is this rectangle outline. That'll be copied over. So, the first bit that we turn on is this one here.
1.
And that's the light that turns on. I'll just go over to show you. Now we have 2 lights on. The reason for that being is that 0 is the default light. That's the light that will always be on right now, because I don't have the proper mechanism right here, because I'm not going to spend all my time building that when I have to build a main one. We're going to have 8-bit memory modules copied over to make 16 bits, perhaps even a few, maybe 8 bytes, and then we'll have a controller for that instead of having a controller for each and every module. So now I'm going to reset, and the only light that should be on is 0, is that right?
Yes, 0's on.
Okay, and what number now?
Number 2.
Number 2. And we reset, and now 0 should be the only one that's on.
Yep.
And we do this one.
4.
Number 4. Reset. 2 of them.
1 and 3.
1 and 3. That's because I set this one first and that one after. That's manual. In the actual computer, both of these be sent at once, which means that this whole circuit here will actually work properly, because, well, it's kind of hard to explain. With a latency with manual, you get 2 signals sent out at once. That being the one to send off the first number and the one to send off the second number. When I do both of them instantly, it'll send off only one command, making only one light turn on. So if I reset, oh sorry, I got to turn those off, and then reset, we should only have 0 on.
Yeah, 0's only on.
And then we set all of them on, and that'll give us a different number. Then we can reset those, then reset everything. There we go.
0.
Back to 0. That's just a quick demonstration of how this will all work. It'll work a lot better in the upcoming version, but for now, that's it. Thank you very much for watching, and please subscribe.